Hello everyone. Let's solve or try to understand how to solve stoichiometric problems part 2. So in the part 1 video, we have understood how to solve for problems based on mass-mass relationship. In this video, we are going to introduce volume factor and we are going to solve problems based on mass-volume relationship. For this, let's start understanding the first question. As in part 1, I had already mentioned that the question itself gives you a lot of hints on what is expected and what you need to do. Okay, so they are asking us how many liters, that is volume, of oxygen at STP, standard temperature and pressure, are required. See, whenever you see the term required, needed, utilized, meaning the compound or the molecule happens to be a reactant. To burn completely, again, to burn completely propane. That means in this reaction, they have given us nothing else but only the reactants. They have given us propane given by the formula C3H8. They are saying that propane is burning in the presence of oxygen. We always know that whenever a hydrocarbon burns in the presence of oxygen, we are bound to get two products, that is CO2 and H2O. That's basic organic chemistry that we need to know. Let's start by balancing this out. 3 carbons on the reactant side, 3 carbons on the product side. 8 hydrogens on the reactant side, 8 hydrogens on the product side. Let's calculate oxygen. On the reactant side, we have 2 oxygens, whereas on the product side, 3 2s are 6 plus 4, 10 oxygens. So we can simply put a coefficient 5 over here and the reaction becomes pretty balanced. Mind you, this is one of the type of questions where only reactants are given. There is no mention about the product. So under such conditions, having some basic knowledge of organic chemistry always comes handy. So let's start with the first rule that we had seen. First, you need to write the equation, balance it out. Second step is to find the molecular weight. Now, let's try to find the molecular weight of this compound, that is propane. 3 times carbon plus 8 times hydrogen, right? Carbon's atomic mass is 12. Hydrogen's atomic mass is 1. 3 12s, if I'm not wrong, it should go as 36 plus 8. So propane has a molecular weight of approximately 44 grams. Now they are asking us how many liters of oxygen. So for that, we need to remember one simple rule that 1 mole of ideal gas, that is any stable gas, ideal gas occupies a volume of 22.4 liter. Now this is something that we need to know back of the hand. It's very important. It's not given anywhere in the question paper, neither you can find it in any reference book. But during the examination, definitely it's not going to be mentioned. You need to know that any ideal gas like O2, H2, N2, okay, all these are going to occupy a constant space of 22.4 liters. Okay, that becomes the volume perspective. So let's see over here. If 1 mole is occupying 22.4, we have 5 over here. So 5 into 22.4. 4 5s are 20. So it should become almost 112 liters. Okay. Let's come over here. 3 carbon plus 6 oxygen. So 3 12s are plus 6 16s are 3 12s are 36. 6 16s are 6 6 are 6. It should be 96. Okay. So the total of CO2 comes out to be 132. Okay. Let's see H2O. H2 is 4 times 18. Okay, 4 times 18 is 72 grams. Okay, so with this we have found out the molecular weight and the volume occupied by O2. Okay, so unless and until you have an ideal gas, you need not stress upon finding the volume. Okay, since it's mentioned that liters of oxygen are to be found, that's why we are taking into consideration volume perspective. If liters was not mentioned, they were asking about gram, we would have continued the way we did in the part 1 session. Let's go ahead. Let's try to narrow down on what we have got. Our equation is C3H8 plus 5 times oxygen, giving you 3 times CO2 plus 4 times H2O. Okay, C3H8, we just got this to be 44 gram molecular weight. Oxygen is 112 liters. CO2, if I am not wrong, it's 132, yes, 132 grams. Okay. Then we have got water, that is 72 grams. Up till here, please try to take a minute and analyze whether you're getting the right answer. Okay. Okay, once you have analyzed, let's try to narrow down on the given data. The given data states that, okay, how many grams? 2.2 grams of propane are completely burned. How many? 2.2 grams of propane are completely burned. And to burn this, how much? How much liter or how many liters of oxygen is required? So a simple correlation, you need not stress further. Okay, so we know C3H8 and CO2, sorry, oxygen have a coordination over here. We have 44 grams of propane and we have 112 liters of oxygen. They have given us 22 grams of propane and X liter. Simple notion that we have followed, cross multiply. X liter of oxygen basically is 112 into 2.2 upon 44. 112 into 2.2 upon 44 might come close to 5.5, 5.6 liters of oxygen. Okay, so when you calculate, you'll be able to get through this. Again, we are utilizing the same 4 steps. First step being write the equation, balance it. Second step, molecular weight. In this case, we have volume. Third step is understanding what is given and what you need to find out. Fourth step is simple cross multiplication. Even with this much, you are able to solve any type of stoichiometric problem. Let's try another one. They are giving you some information. So first, try to grasp on the information. They are saying a piece of zinc, okay, weighing 0.635 gram when treated with meaning reactant A treated with reactant B, dilute H2SO4. So there are two reactants, zinc and H2SO4. Liberate meaning product. Product happens to be hydrogen. Okay, calculate the percentage purity of zinc sample. So basically, there are two questions in one. This is question 1 and this is question 2. Let's try to first analyze question 1. They have given us what are the products. They have said there is zinc and zinc is treated with H2SO4. Okay, liberating hydrogen gas. Now we know if hydrogen is removed from the equation, zinc reacts with sulfate to give you ZnSO4. Okay, so let's see whether it's balanced or not. Yes, it's balanced. Now, what is being given over here? Zinc weighing something treated with H2SO4 liberates hydrogen. Okay. Now, first try to understand what is the step number 2. Step number 2 is finding the molecular weight. They have given molecular weight is 65.3 grams. H2SO4, 2 times hydrogen plus 1 times sulfur plus 4 times oxygen, giving you 2 ones are plus 1 times 32 plus 4 times 16, right? So this happens to be 2 plus 32, 4 16s are 64. 32, 64 should be giving you approximately 98 grams. Okay. Hydrogen, again, we are talking with respect to volume. So since hydrogen is an ideal gas, we are going to consider its volume. It's only 1 mole over here, so we are considering it as 22.4 liter. Okay, 1 mole of ideal gas occupies a volume of 22.4 liter. Let's try to understand for zinc, 65.3 plus 32 plus 64. This results into 5.3264. When we add it, we are getting 161.3 gram. Okay, so we have completed successfully step number 2, where we have calculated molecular weight, and in with respect to hydrogen, we have done it as volume. Okay, let's move on to step number 3. Step number 3 is first of all writing down what we have got. Zn plus H2SO4 giving H2 plus ZnSO4. Zn is what? 65.3 gram. H2SO4 98 gram. Hydrogen 22.4 liter. And this came out to be 161.3. Let's try to understand what is given. Okay, they have given us two things. They have given us the weight of zinc, and they have given us the volume of hydrogen. So let's say weight of zinc has been given 0.635 gram. Volume of hydrogen has been given 200 centimeter cube. Now let me tell you one thing. 1 liter is equals to 1000 centimeter cube. So 200 centimeter cube equals to x liter. Cross multiply, you would understand it would be 0.200 liter. Okay. So now we can write either 200 centimeter cube, or you can directly present it in liters. How many liters are we looking at? We are looking at 0.2 liters. We just erase this up. 0.2 liters. What do we want to find? Here comes question number 2. Okay, what do we need to find? What is the major idea? We need to calculate the percentage of zinc in the sample. So we need to find how much zinc is there in the sample, right? So we can't consider the weight that has been given for zinc. Okay, we want to find how much zinc is present. So what we would do, we'll take zinc with respect to hydrogen. Take the calculated molecular weight 65.3. This becomes 22.48. Okay. We'll take zinc as x grams because we want to calculate the percent purity of zinc. So that is the to find. Okay. And over here is 0.2 liters. Let's try to solve for x. X is equals to 0.2 into 65.3 upon 22.4. Take a minute, try to solve. 0.2 into 65.3 would result, I guess, into 13.06. And this would be 22 by, okay. So your value of X, that is zinc, in the sample right now would come approximately near to 0.5859. Okay, so 0.58 or 59 gram of zinc is present in the sample. Whenever we solve such questions, because of repeated practice of the question, there might be times that I know certain values. So that does not mean that, I'm some super fast mathematician or something. No, it's simply because I've calculated it a lot of times. For you, if this question is new, you might take some time, you might get some other answers. Feel free to, experiment with your questions and answers. While you're practicing, that is the only time to experiment. During examination, while you're solving it on a paper, you can't sit and experiment what to do, what not to do. Okay, so even if you get some answers which are deviating, it's okay. If you get instead of 0.58, you get it as 0.6, okay. Nothing's going wrong over here. Approximation does not kill. Okay, we have completed understanding how much zinc is present. So let's try to move ahead. Okay, so how much zinc is present in the sample? 0.58. How much zinc they are giving us? They are giving us 0.635 for the reaction. Let's try to calculate the purity. If you want to calculate percent purity of zinc, it can be calculated in a very simple manner. It would be calculated weight upon given weight. Since we want to get a percentage value, we are simply going to multiply it by 100. So you can see calculated weight is 0.58. You can consider it as 0.6 upon 0.635 into 100. You might get an answer that is pretty close to 90%. In this case, you might get an answer which is approximately 91.33. So when you calculate, you might result into this answer. Even if you stop your answer at 91 or you get it as 92, you get it as 90, it's okay. Nothing's going bad. Little bit approximation never hurts anybody. If it's speeding up your reaction or your calculation, go with it. Okay. So I hope you have understood at least 10 to 15% of what has been taught. Rest of which you need to practice by yourself. You can only hear me out for a little period of time, but then what you practice is going to show the result. So do not just hear out the conversations like it's some kind of a book telling or storytelling competition. Try to analyze the question by yourself, then solve it, and then go for understanding what is the solution. If suppose you have solved and you're getting a solution that's differing, then you sit and rewind the video, try to analyze the video again, and check where you're going wrong. Do not consider this to be just merely 2, 3 questions which are given, and you're going to, rote memorize it, or you're going to just mug it up. Don't do that. It would be harmful for you in the long run. Okay? If you have understood the 2 questions that we have done prior, you might be able to solve this question. So try it for yourself. Here we know again the same rules apply. First of all, construct an equation because I have not given an equation over here. Construct an equation and balance it. Okay. So how do we go about it? What is given? They are saying how many grams would be consumed. So how many grams of iron would be consumed? Consumed meaning reactant. When some quantity of oxygen is utilized, again a reactant, to form, meaning a product, Fe2O3. Rusting process has been demonstrated over here. 2 iron, yeah, okay. So iron is over here, it is combining with oxygen to give you Fe2O3, which we commonly call as dust. So this is the basic construction of the equation. I want you to utilize some time to sit and balance out this equation. Once it is balanced, you can go to find molecular weight and volume. Molecular weight and volume. So only one ideal gas can be seen over here, that is oxygen. So you know oxygen would be 22.4. Okay. Third one would be analyze what is given and what you need to find. And the final step would be cross multiplication. With these 4 simple steps, you would be able to ace the stoichiometric problems. Okay, I hope you all have understood what was taught in this particular lecture. Okay, in case of any doubt, please feel free to put it in the comment box. And if not, I hope you have 100% understood how to try at least, or how to at least go about the stoichiometric equations. With that, we stop the lecture. Signing off. Bye.